So now we will study the hydrostatic forces. So what is hydrostatic forces? So the forces acting on the floating bodies and on the submerged surfaces due to fluid pressure are called as a hydrostatic forces. So determination of hydrostatic forces is important for design of many engineering systems like water dam, that is your hydro dam, then storage tank, hydraulic press, etc. In order to describe the hydrostatic forces, we need to give its magnitude, direction, and the line of action of these forces on the submerged or the floating bodies. Okay. So these hydrostatic forces we calculate based on the hydrostatic law. Okay, so hydrostatic law, it gives the pressure equation, which is a rho gh. So depending on this height, okay, we will get the variation in the pressure. Okay, so this pressure, it will act on the submerged surface, and we have to find out what is the net force created because of this hydrostatic pressure. Okay, so that calculation we will study in the hydrostatic forces. So for the hydrostatic forces, we will calculate total pressure, and second, the center of pressure. Okay, so what is meaning of total pressure? So it is defined as the force exerted by the static fluid on the surface, either plane or curve, when the fluid comes in contact with that surface. So it is the force exerted by the static fluid on the surface, which is either plane or curve, when fluid comes in contact. Okay, so that is called as a total pressure. So total pressure, it is nothing but the force. So this will be F and its unit will be Newton. Okay. So as the name is total pressure, it doesn't mean that it is in Newton per meter square. Okay. So it will be force and its unit will be Newton. So it will be acting on the plane submerged surface or the curved surface. Okay. So we will take simple example. So here we have the wall, like this. Okay. And one side of this wall, we have the liquid, which is the water. Like this. So this water, it will exert some force on this wall, and calculation of that force is nothing but the total pressure. Okay. So that force, it will act somewhere on this wall like this. So this is the force F, which is called as a total pressure. Okay. So total pressure, it is represented as F. And this total pressure will have some distance with respect to the free surface. So this is the free surface, or this line is nothing but the free surface of that water. Okay. So from this point, if you measure this vertical distance of this force, then this is called as a center of pressure. Okay. So center of pressure is defined as a H star. So definition for center of pressure is the point of application of the total pressure on the surface, total pressure on the surface. Okay, so this center of pressure, it is nothing but H star. So here you can see this is the free surface of the water or the fluid. With respect to this free surface, we measure the distance where the force is acting. Okay, so that distance is nothing but the center of pressure, and this is called as a total pressure. So what is the formula to find out the center of pressure? So just I will show the front view for one submerged surface. Suppose one surface or one plane object, okay, it is submerged in the water. Like this, okay. So on this object, this is the point where the total pressure will act. Okay, so at this point we will have the F force. So if you draw the side view, I will show the side view like this. So if you observe from this side, that is from the right side, you can just observe one rectangle. Okay. So on this point, we will have the center of pressure. So this is the, sorry, this is total pressure. So this is the F. Okay. So this point is represented as a point P. That is called as a center of pressure. So center of pressure means with respect to the free surface, this height is nothing but center of pressure. That is a H star. Okay. So this H star we can calculate by using this formula. Or first we will write the equation for F, which is the total pressure. So F is equal to, it is rho G A H bar. So what is H bar here? So H bar is nothing but the position of center of gravity of the surface with respect to the free surface of the liquid. Okay, so suppose for this submerged object, okay, this is the center of gravity. So this is the point G. So if you measure this height from the free surface of the water, so it will become the h bar value. This area A, this is the total surface area. Surface area in contact with the fluid. So we have to find out this total area. Okay, so that is nothing but A. Rho is the density of the fluid. So by using this formula, you can find out the total pressure that will be acting on the submerged object or submerged surface. Okay. Now this H star value, that is nothing but center of pressure, we can find out by using this formula. So center of pressure so this is given by this H star is equal to this is Ig upon AH bar plus H bar. Okay. So here this Ig, this is the area moment of inertia. This is area moment of inertia of the submerged surface about its center of gravity. So about its Cg, and h bar is same. It is the position of center of gravity of the submerged surface with respect to the free surface of the liquid. Okay, and A is the total area in contact with the liquid. So in this way, you can find out the H star value. That means where the pressure, total pressure is acting. So you can refer the derivation in your book for total pressure and the center of pressure. Okay. So I will give this derivation in your assignment. Okay. So just go through the book. Okay. So now I will show what is the application of this total pressure and the center of pressure in the water tank. Okay. So this concept of calculating the total pressure or the center of pressure, it is used to control the movement of the water gate in the hydrodynamic. Okay, so here you can see. So actually, this is not a gate; it is the water dam. So this is the wall. So this is wall of the dam. Okay. So actually, the hydrostatic pressure it varies with this equation. P is equal to rho gh. Okay. So if you observe the pressure at this point, so this is the free surface of the water. So there is no height above this layer. So here pressure will be zero. Okay. So as we move inside the water or as we go deep in the water, then this pressure will increase. So at the bottommost layer, we will have the maximum pressure. So suppose this total height with respect to free surface, this is equal to h. Then at this point, pressure will be rho gh. So here you can see this is the uniformly varying flow. So you must have studied this UDL and the UVL concept in your engineering mechanics. Okay, so pressure in the water, it is uniformly varying from free surface to the bottommost layer. Now this pressure will act on this wall of the dam. So while designing the dam, engineers need to consider this pressure variation, and from this pressure variation, they will find out the resultant force, that is called as the total pressure. Okay, so this total pressure is nothing but the F value. Okay, and also they will find out the position of this total pressure with respect to the free surface. Okay, so by calculating this total pressure and this H star, we can design this complete structure. Okay, so this is one application behind calculation of the hydrostatic pressure. Okay, so this is the automatic gate opening mechanism in the water dam. Okay, so I have just represented this schematically. So here you can observe, this is the gate. Okay, so when the water is at the low level, then this gate must be in the closed condition. Okay, so it will not allow the flow of water in the downstream side. So gate is closed. So as the water level will increase, and if it crosses some limit level, okay, then this gate it will open, and then it will allow the flow of water in the downstream side. Okay, so here you can observe, this is the initial water level. It will have some height. Okay, so when it is having some height h, this is the total pressure. Okay, so resultant is acting below this hinge point. So gate is hinged at this point. So this is the hinge. So hinge means it will allow the rotation, but initially net force is in the downward side of the hinge. So your moment is like this, anti-clockwise. Okay, so this force will try to rotate the gate in the anti-clockwise direction, but there is a stopper. So this is the stopper. Okay, so this stopper will restrict this anti-clockwise movement. So gate will remain closed. So water level will start increasing like this. Okay, so as the water level increases, this F force, it will shift in the upward direction. And once the force F shifts above the hinge point, then it will create the clockwise moment. Okay, so here you can see this moment, this is clockwise. And only the clockwise moment it can rotate the gate, and therefore it will allow the flow of water in the downstream side. Again, if the water level decreases, then the resultant force will shift in the downward side. Okay, and it will slowly close the gate. Okay, so here you can see the force is shifting in the downward direction. So this is the application of the pressure or total pressure and the center of pressure. Okay, so when we will solve the problem on the submerged surfaces, that is to calculate the total pressure and the center of pressure. So you will need this formula. So these are the standard shapes. Okay, so you can take this screenshot for your reference. So what is given here? Your first column is the standard surface. So right now it is a rectangle, and if it is having the side B and D, then its center of gravity with respect to base. Okay, so it is at distance b by 2. Area is b into d. Moment of inertia about the axis passing through the CG and parallel to the base. So that moment of inertia is nothing but moment of inertia about this axis. Okay, so this is nothing but Ig. So this value is Bt cube by 12. And moment of inertia about the base, that is I0. So here base is, this is the base. Okay. So about this axis, moment of inertia is I0. So this value is Bt cube by 12. So we are just interested in the moment of inertia about the center of gravity. Okay. So the standard formula is given in this chart. So second is for triangle. Okay, take the screenshot. This is for circle and trapezium. So when we will solve the problem, we will understand how to use this formula to calculate the center of pressure and the total pressure.